Edexcel A-Level Maths, Pure Paper 1, June 2022, Question 5. The height h metres of a tree t years after being planted is modelled by the equation h squared equals at plus b for t between 0 and 25, where a and b are constants. We're given that the height of the tree was 2.6 metres exactly 2 years after being planted, and it was 5.1 metres exactly 10 years after being planted. We need to find a complete equation for the model, giving the values of a and b to 3 significant figures. So we've been given 2 sentences there with pairs of numbers in them, which we're just going to put into our equation. So for the first one, we've got the height, 2.6 squared, is going to be equal to a times by our time, 2 years, plus b. Squaring 2.6 gives us 6.76 equals 2a plus b, which I'm going to call equation 1. We're going to do exactly the same thing with the second sentence now. So now it's 5.1 squared, and that equals 10a plus b, which gives us 26.01 equals 10a plus b, and that's equation 2. So we've got 2 simultaneous equations. We need to find a and b. As both of these equations have just got plus b on the end, if we subtract them, that b is going to cancel out. So I'm going to do equation 2, subtract equation 1, just because equation 2 has got the bigger numbers. So on the left, we've got 26.01 minus 6.76, which gives us 19.25. And then the 10a minus the 2a gives us 8a. Dividing through by 8 gives us 2.40625, which to 3 significant figures is 2.41. Now we've got a, we can put this back into either of those 2 equations to work out b. I'm going to put it back into the first one. So 6.76 equals 2 times 2.40625 plus b. Note that I'm using the full version of a rather than the rounded one. So I'm just doing this for accuracy. If we then subtract the 2 times 2.40625 from both sides, we get that b is equal to 1.9475, which rounds to 1.95. We're asked to find the complete equation, so we need to rewrite out that equation now with our a value and our b value. So h squared equals 2.41t plus 1.95. Given that the height of the tree was 7 metres, exactly 20 years after being planted, for part B we need to evaluate the model, giving reasons for our answer. So we've got our model that we worked out in part A, we've got our values of 7 metres and 20 years. So we just need to put either of those in, the 7 or the 20, and see what we get out and see whether it's close or not. I'm going to put the time in, so our h squared is going to equal 2.41 times by 20 from the question, plus 1.95, which gives us 50.15. Square rooting this will give us h of 7.08. So let's compare this to the heights given in the question. 7.08 is very close to 7 metres, so we can say that it is a good model. For this question, we could also put the 7 in as h squared and worked out what t would get out. Again, we'd get a t quite close to 20, so we get the same answer, that it's a good model. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.